Hi, I'm Cole Weinland, and I'm a senior in mechanical engineering at CSU. And I set out on this report to to test the feasibility of the continuation of use for titanium vanadium alloys in bicycle frames. And basically, that means that for the past 7 years or 8 years, titanium has been the go-to material for racing bicycle frames, and I wanted to test the feasibility of continuing using that. Material science has come a long way, and there are some other contenders now. Brief introduction. Bicycles were first designed over 200 years ago, and the original design hasn't changed much since then. And so what has changed is the material that people have used in the bike frame. Bikes are also the most efficient machine ever built, more efficient than airplanes or cars or even the Albatross. Materials that you choose have to be able to withstand certain stresses and loads that people and riders put on it. And material science has been constantly changing since the Iron Age, really. A good way to test this is using finite element analysis, which is a computer program that can break up a model into tiny pieces and mathematically calculate the stress and the elongation. There's basically three materials today that are used in bike frames. One is titanium, aluminum, vanadium alloy. One is aluminum 6061, which is a heat-treated form of aluminum. And the other is carbon fiber, which is a fairly recent material that has come to use. Each one of them have their own strengths and weaknesses, but there is not one in particular that is good in all departments. So a few things that we have to consider for this test is our mechanical properties, which basically is the strength of the material and the hardness of the material and corrosion. All these kinds of things go into designing a bike. And when you test it on the computer program, you can change these inputs, and based on those, you can see how much they will bend or how much if they'll break, basically. So the first part of the test is to see if any of them break. So you go and you look and see what is the Young's modulus for carbon fiber, or what is the Young's modulus for titanium, and you test it in the program. Make sure that nothing reaches the yield stress or the ultimate stress, which is where things start to really go wrong. And if you're riding a bike, you would crash, and if you're riding a bike really fast, you might die. So first, doing all of these tests in the FEA software, none of them reach the critical stress, which is good. So none of these three materials would break. And the second thing you have to test is cost-effective analysis. So basically, you can assign a value to each of your variables. So the three that I chose were cost, weight, and strength. Weight was the most important because the more it weighs, the more energy you have to put in to ride it. Cost is the second most important, which you can imagine if not everyone has unlimited money. And then strength is the third most important. So weight 1, cost 2, and strength 3. Using something called a weighted sum method, you can quantitatively analyze the US material. So knowing that weight equals 1, cost equals 2, and strength equals 3, you can pick how these materials rank. So titanium is a very expensive metal to refine, so its cost is a 3. And then you multiply the weight of the cost by its rank, so 2 times 3 is 6. Doing all these for each material, you can see, and then you pick out which one has the highest number, and the highest number means it's the best material. And after doing this, it turns out that titanium has a 14, carbon fiber has a 12, and aluminum has a 10. So even after all this time, titanium is the best material to choose. Titanium has other uses also in the medical industry, in the aerospace industry, and ballistics industry. So Go with titanium.